In this video, we'll briefly discuss triple integrals or introduce them. So triple integrals, just the next step when you go from functions of 2 variables to functions of 3 variables, but it pretty much works the exact same way as double integrals worked. So what we do is we have a function of now 3 variables x, y, and z, and some domain in R3 in 3-dimensional space. So this would be a solid, maybe a solid rectangular box, for example, with x changing between a and b, y changing between c and d, and let's say z changing between r and s. So these are constants, but they could be functions as well, giving you some surfaces in between. You take the x and y and z. But the point is that to evaluate the triple integral of this function f of x, y, and z over this domain, this region in space, we need to take the limit of a triple Riemann sum, which is just summing over the function's values taken at some sample points multiplied by some small volume formed by the subdivision of the x, y, and z intervals. Each subinterval would have along the x-axis would have a length of delta x, a length of delta y along the y-axis, a length of delta z along the z-axis. So the length of each rectangular box would give you a volume of this size, and each of them are multiplied by the value of the function. And let's say we subdivide the interval AB into m parts, the interval CD into n parts, and the interval RS into L parts. But the point is that all of these numbers have to go to infinity to take the limit of this triple Riemann sum and to obtain the triple integral of our function f of x, y, and z over that domain. So this is the basic idea. It's pretty much just a added variable in the story that we've seen before. And to show you an example, let me ask you a question. So let's have B, this rectangular box, be the Cartesian product of the intervals 0 to 1, minus 1 to 2, and 0 to 3. So this is our region in 3D space, x changing between 0 and 1, y changing between minus 1 and 2, and z changing between 0 and 3. And let our function of x, y, and z be x times y times z squared. And I'm asking for the triple integral of this function over the domain B. Pause the video and compute this integral below. Okay, I hope you paused it and realized that the way we do it, well, the way we can do it in this case is just iterated integrals. So we integrate f of x, y, and z, let's say first with respect to x, with x changing between 0 and 1. Then this way we get a function of y and z only. Then we may integrate with respect to the y variable, with that changing between minus 1 and 2. That will give us a function of only the z variable, and then we can finally integrate with respect to that remaining variable z with that changing between the 0 and 3. So let's do that. So the innermost integral, so this is, let's not forget, is x times y times z squared. So what we have is, in the middle, is x squared over 2 times y times z squared. So y and z squared are just treated as constants for the moment, and x changes from 0 to 1. And then we integrate with respect to y, and then we integrate with respect to z. So that evaluated gives us 1/2 times y times z squared. So now we can move on to integrate with respect to y to get 1/2 times y squared over 2 times z squared, as y changes between -1 and 2. So when we evaluate that expression, we'll get 2 squared over 4 times z squared minus -1 squared over 4 times z squared. So really what we have here is z squared minus 1/4 of z squared. So that's just 3/4 times z squared. Then we integrate with respect to z as it changes from 0 to 3. So what we really get is 3 times z cubed over 4 times 3. We can simplify by 3 as as z changes between 0 and 3. Okay, so we have z cubed over 4. So when z is equal to 3, we have z 3 cubed over 4, and then we have minus 0 cubed over 4. So what we have here is 27 over 4. Okay, I hope you enjoyed this video, and I'll see you in the next one.